In this video, we're going to see how to find the inverse of a function. So given one function, find the inverse of it. The process for that is that first, if it's written in function notation, you're going to write it in notation with y. So you're going to replace f of x with y. Then the second step is that x and y are going to switch places. So you would rewrite it again. Where the y is, you would put an x. Where the x is, you would put a y. And then the last step is that you're going to solve the resulting equation for y, or in other words, get y by itself. So we're going to look at example 4. It says to find the inverse of f of x equals 7x minus 5. So first I'm going to replace f of x with y. So that would be y equals 7x minus 5. Now x and y switch places. So this y becomes an x. The x becomes a y. So we have x equals 7y minus 5. And then my last step is to get y by itself. So solving for y, I need to add 5 to both sides first. That gives me x plus 5 equals 7y. And then lastly, divide both sides by 7. So I get y equals x plus 5 over 7. Now in the homework, you're going to see they're going to use the function notation with the -1. So let's say f of -1 or f -1 of x equals, and then you'll type the answer into the box right here. So you would type x plus 5 over 7 for this one. So that's the answer. So next you should try checkpoint problem number 4. Do this in your notes, check your answer, and then move on with the rest of the video. Next, we're going to talk about inverse functions when you have a graph. So if you have a graph of a function and you want to find the inverse, then what you do is for any point, you can switch the x and y coordinates. The graph of the inverse will look like the original graph, reflected over the line y equals x. So we're going to look at example 7. It says use the graph of f to draw the graph of its inverse function. So looking at this, what I'm going to do is I'm going to look at the points and use that to draw the inverse. This diagonal line here is the line y equals x. So it should look like it's reflected over that line. So looking at this point here, the coordinates are going to be 4, 2. So that means that my point on the inverse, I would switch the x and y around, so 2, 4 would be a point on the inverse. So I'll plot that right here. So let's go to another point. The coordinates of this point are -1, 0. So 0, -1 is a point on the inverse. And I see that those 2 points are connected with a line on the original graph, so I'm going to connect them with the line on the inverse. And you can kind of see, I didn't draw it too well, but you can see how this is going to be a reflection of the red line over the gray line, y equals x. And then my third point here, the coordinates of this are -3, -2. So on the inverse, I would have -2, -3. So that's down here. And then that is connected with a line to 0, -1. I'll draw that in. So that would be the graph of the inverse. And again, you can see, if you kind of turn your head sideways, you can see that it should be symmetric over the gray diagonal line. So next you should do checkpoint problem number 7. This is similar, except now instead of giving you the graph, they're giving you the points to draw. So you have to draw the original function f with these 2 line segments and then use the coordinates to draw the inverse. And you'll see the answer to that in the notes. So do this in your notes, check your answer, and then move on to the homework.